Going well. So today I'm going to show you something that's going to be really important for your project, which is going to be adding an additional control variable. And so if you go and look at the final project assignment, you'll find the kind of what you need to do in this document right here that you can click on and it'll open if you just look at it in Canvas. And so this top section is that we looked at before. This is the minimum you must do when revising your project draft you submitted to the final. So that you submit to the final must include the following. So first off, fix anything I mentioned in the comments that I made. Discuss the statistical significance of all slope estimates and other regression statistics. So that's going to be like R-squared, p-value, stuff like that. And then third, you're going to have to add at least one control variable. So to add that control variable, basically, I'm going to show you how to do that today. And that's going to be important because that's going to be one of the minimum things that you'll want to do. And then notice, even for the later on stuff, so to get that A or B, this stuff down here, add even more control or independent variables to the model will be a good thing to improve it enough to get an A or a B grade. So I'm going to show you how to just add one today, but in future videos I'll show you how to add more. So I collected cross-sectional by country data, and our dependent variable is going to be deaths related to the coronavirus that we've seen so far. So I downloaded this data today, March 23rd. And then total cases will be our first independent variable. So we'll be asking kind of, if cases increase by 1, what is the rate of increases in deaths related to the virus? So those are probably going to be positively correlated, right? Because if there are more cases, there's likely to be more deaths. And then we're going to add GDP per capita as a control variable in a second, because maybe more wealthy countries are more able to fight the virus or to help people who have the virus, leading to fewer deaths. Or it's also actually possible that more GDP per capita could lead to more cases if it's spreading faster, for example, things are getting overwhelmed faster. Both of those are actually possible. And if both of those are happening at the same time, they could even like wipe each other out and we wouldn't even see an effect on GDP. So we'll ask those questions today. So first we'll start off by doing just a simple linear regression in Excel. So just starting with our first independent variable, cases over here. So I open Data Analysis Toolpack, push OK. I'll get rid of this because it often preloads the last thing you did, which is, I obviously tested this first, so I did this already, but I want to start. You're going to have a blank sheet. I think this is the default of how it starts right here if you open a new window without preloaded stuff. So our input Y range, our dependent variable, will be deaths right here. So I'm going to click on the word deaths, Shift Command down arrow, or Shift Control down arrow if you're in Windows. Then our X input range, so for the simple linear regression, we'll just do cases. So just our one main independent variable. I included labels. And so let's go ahead and put that output right in this same worksheet. So I'll click on output range, and then I'll click on F2 right here. That seems like a good place to load that. Push OK. And there are the results from this simple linear regression. So again, we have our three main things we care about are the slope estimate right here. So across countries, when coronavirus cases increase by 1 in our data, deaths increase by 0.05 on average in our data. Notice that that basically says that there's about a 5% fatality rate in this particular data. That's probably overestimated just because of the nature of the data. People who have coronavirus and have very mild symptoms, we probably never even see that case, so they're not even counted in this row. But as a first kind of basic estimate, in our data, when coronavirus cases increase by 1, fatalities increase by 0.05 on average. Now, next question, is that a statistically significant slope estimate? Yes, it's very statistically significant. This is an extremely tiny p-value written in scientific notation. So 2.636 e negative 44 means that you have a decimal point, then you have 43 zeros, and then you have 2636. So that is an extremely tiny probability of observing this slope estimate if there is no relationship between the independent and dependent variable. So that is very statistically significant. Now, what about the fit of the regression? We can go up here and look at our R squared value, 0.768, so about 76.8%. And so how we would interpret that is we can say that coronavirus cases explain, or actually I should say it to be more clear, variation in coronavirus cases across countries explain 76.8% of the variation in coronavirus deaths across countries. Now, that's kind of an interesting thing to think about because it's not 100%. If it was 100%, that would mean that there's a constant kind of 5% fatality rate across countries, but as we know, that's probably not true if you've been following the news. For example, Italy has a much higher death rate per case than, for example, South Korea did. And that could have to do with a bunch of other factors. Those other factors, by the way, explain 1 minus this right here. Notice those two things add to 1. Because the variation in deaths explained by cases plus the variation not explained by cases must equal 1. So that's another kind of cool thing you can do with the R squared is look at, well, how much is not being explained? That can often be very interesting, especially if you get an R square that intuitively you should have thought should have been bigger. You can write an interesting sentence about this leftover variation. So now getting to the main part of the video is we want to now add this control variable right here. So the way we do that is we click Data Analysis again, click Regression, and it's kind of nice when you're doing this, and I encourage you to do it this way. Do your simple regression, and then right below it, put your first multiple regression, because then it makes it really easy to compare and contrast across regressions. And all we have to do is we can delete this right here. And now notice, I haven't mentioned this yet, but in this time, I put my dependent variable to the left. And the reason I did that is now I can put my independent variables together to the right. Because this X dialog box will actually accept more than one column. So I'm going to go and highlight both of those column titles, Shift, Command, down arrow. So now instead of having C1 to C137, I have C1 to D137. So I'm highlighting that whole rectangle. Okay? And now, if I go and put this, I don't want to overwrite my old results, so I'll put it down here in F22. Click OK. There's our new regression results. And now what do we see? So first let's compare, let's ask, did our coefficient on cases change much from one regression to another? No, it's actually extremely close to what it was before. But we'd have a slightly different interpretation. Now we would say when cases increase by 1, deaths increase by 0.052 on average in the data, holding GDP per capita constant, because that's that extra thing you have to say when we are looking at a multiple regression, holding the other variables constant. Now let's go ahead and interpret the slope on our new independent variable. When GDP per capita increases by 1, deaths tend to decrease, but by a very small amount on average, minus 0.00088. And that is not statistically significant because that p-value is pretty big. There's a 27% chance that I'd be wrong if I were to say that this is an influential variable right here. notice the p-value on cases is still extremely tiny, like it was before. Okay? Now, another thing, you guys have been looking at significance F a little bit. This is kind of the statistical significance of the overall model. Notice here, because there's only one independent variable, the overall significance and the significance of the overall significance p-value and the p-value for the one independent variable are the same because that one independent variable is the whole model. But now in this case, we get one that does not match either of these two because now we have a model with two independent variables, and both of these are tiny p-values, so we would say that the overall model is statistically significant in both of these cases. But the main point of this video is I wanted to show you how to implement multiple regression in an Excel. So now we have two independent variables, and you'll want to do that for your project again as kind of one of the main extra steps you're going to take going to your final project. All right, thanks.